In Cosmos, there are a few different node types, but these are all running on the same daemon. So we have validators, we have full nodes, and we have archive nodes. These each serve a different purpose, but are required for different activities on the network. For validators, their whole point is to sign blocks. All they need to do is submit signatures, verify transactions, and make sure that no double signs happen. This is all done automatically under the hood. A full node can become a validator node. So if you're running a full node now, all this takes is that you create a validator on that node, you save that private key that is going to be used to sign those blocks, and then it's going to, as you've already connected with the peer-to-peer network, begin to validate transactions as you have enough vote power. Vote power is derived from stakers. We can see this here in this list. If we go to the very bottom, we can see that if you have 100,000 Atom, you could be in this set and you would be number 180, 179 in that range. So it requires enough voting power and you will take a portion of that, but really it's just a full node under the hood that is locked down with no public access other than the peer-to-peer network to collect and sign blocks. The next node type is the most common. This is a full node. These can be found on Cosmos.directory as well as the GitHub maintained by the Cosmos organization, that is the chain registry, which this is built off of. So within this, there's an RPC proxy for RPC request, REST request, as well as gRPC requests that you may have. And so you can do this with a variety of different nodes. Many operators will put up their nodes here for free public consumption. These can and will be rate limited. So depending on the different providers, there are some that may not rate limit and others that heavily rate limit. So you need to be aware of that. It may be useful to round robin between multiple of these. This is also useful for CLI checks as well as on websites that you need access to a certain network. You'll typically use the RPC via something like Cosmos.js. And so here we just have these. We can use these for relayers as well. We can see when the last time the check was, what errors have happened on it, what height is it currently at, and if it's available, which is if the current height is within the range of expected values for where other heights are also at. So here we can take this RPC and we can now see that here's the RPC interface, and we can check some basic data such as what is the version of this on, when was the last block height, hashes, and different information like that. So if we wanted to actually go query something, we can. Here are archive nodes. So archive nodes are full nodes. So I should back up and say full nodes typically only have about 30 to 90 days worth of data. It's more than likely within the 30 to 40 days worth of data. So once that 40 days is up, that data is then removed. You can no longer query those older heights there. So if we actually head back to here and we go to block and let's search a height. So if we search the current height, we know that this works. But what happens if we wanted a really old height? And we go back to this, the lowest height is that, which is probably going to be about 30 days old. The height is purged, it is no longer there. How do we access that though? Because now full nodes do not have it and validators do not have that data. So the way we're going to get that is actually from an archive node. These are heavy nodes that index and keep all of the past data of the network and ensure that we can sync from that and get that old data there. So if you're interested from a Cosmos Hub archive, you can actually find that at archive.interchain.io, which includes Cosmos Hub 1, 2, 3, and 4 exports. And then here, this doesn't actually go up to latest. What you would do then from there is sync up with other archive nodes via the peer-to-peer network, and you would ask for those blocks and you'll get to the latest. We can also see this for a network like Juno, which actually provides those downloads and the size. As you can see, these are quite large, even compressed files in this instance, as well as the RPC archives for this. So if we wanted this older data, whether that be for analysis or for tax reasons, we can go query accounts from legacy blocks. And so we can come in here and we can now use this not only at the latest height for this network, but also very old heights. For example, if I wanted block 5 million, even though we're at 11 million, typically this would be purged, but now we can go get all of those different transactions. We can check the evidence, who committed on what, who signed, etc. And so now we can actually run back here and let's go run a transaction. So if we're going to run a transaction, we can see this with Juno D, and then we're going to check this always on 443. If it's HTTPS related, you need to add that port there at the end. And so we can now query this and we can now check that data. Now let's say that this provider goes down. You can go back to Cosmos directory. You can go to Juno and go find a different provider in the RPC section. So in this case, we'll use EcoStake. And now instead of that archive node, we could use this node, and it will provide the same data within a couple of blocks of where that other one was, depending on where it is peering. So this is extremely useful for, again, CLI and web apps, and this is what you're typically going to need. But if you do need old data, you need archive nodes. There are not currently solutions for where to find those. A lot of those are either paid or locked down or private within internal of teams, so you'll need to reach out to others and go find that data.